which kind of oil they use, 4, 5, 6, and this is really extremely painful. I'm Lars from LMI Technologies, and here we see a demo from NET, and what they do is typically creating intelligent cameras, smart cameras, and this special model is using a Sony EMX 990, which is a sphere sensor. It's one of the sphere sensors, and they have here a halogen lamp, so black body radiator, which is also emitting in the infrared. And here we have the blue labels, and they are not transparent, but with the InGaAs sensor you can look through the material, so the blue color gets transparent, and we see the liquids when you look on the monitor, and we see the fill levels on the monitor. We see a little bit.
It's a plastic coating. The blue is a plastic coating.
Thick 1 millimeter plastic coating. It gets quite transparent, not fully, but quite transparent. And you see some water-oil mixes. And water has a very strong absorption in the infrared, around 970 nanometers.
That's why it's all dark.
And then water gets more dark than one with oil. I have no idea which kind of oil they use, but if it's mineral oil, there's no absorption, and water has a really strong...
What if it's empty? Would it?
And
it would show fully white.
It would show fully white. Yeah, like here, it's quite transparent. So so this is a special smart camera that is really with InGaAs sensor. Well, this is totally unusual on the market. They have maybe area scan camera monochrome color, and some of them are maybe also with line scan sensor. Okay, here next we have the LMI trade show demo showing battery inspection. So this is extremely fast timing sync box for our sensors, and the Master 810 distributes also the encoder signals from the linear axis, and the three sensors are calibrated together to create this image here. So it's a fusion of multiple images. Later we will see it again. Then next we do some confocal imaging inspection with sub-micron accuracy.
Wow.
So the electrodes on top, they don't... later you do some ultrasonic welding on top, so it must be really quite flat. If it's uneven, you have scratch, some pinholes, whatever, then it's not really good for the next welding process. So that's why we can look with our confocal sensor on very small defects.
So that's one of the, I think, big advantages of LMI, right? You can
we can
buddy
the sensors.
Three systems calibrated
calibrate together. Yes, because calibration in 3D is 3, 4, 5, 6 degrees of freedom you have to calibrate. And when you have 2 or 3, then it's even more worse. So you end up in this case maybe with 24 degrees of freedom calibration. And this is really extremely painful. Next we have the confocal scanner with a line length of around 16 millimeters and a measurement height range around 5 millimeters. And the repeatability is really in the submicron range, 200 nanometers.
Wow.
Or even better. So very, very accurate system. And with the confocal scanners, there's also another big advantage. With a laser scanner, when you look on a very shiny, on a mirror, maybe you can still detect something like 7 degrees tilt. With our glass scanners, it's maybe around 10. And with this confocal scanner of the G5 series, it's up to 20. So you get more from curves, you get more from the jumpers, and or if there's a groove or a scratch, you really get also the sidewalls.
Right.
And the G4 series, our new confocal scanners with very small arrays, they can even get up to 80 degrees angle. surface curvature.
Wow.
So when you do something in
So there's no blind spots.
so no
Very
shadowing.
limited, yeah.
It's
Nice.
it is coaxial, going to a semi-transparent mirror. So looking from the top with the light, with the camera, and there you can go up to 80 degrees. And when you have, for example, a ball grid array in semiconductor, you have really heavily curved object, ball bars.
Yeah.
And this is something that can be fantastically detected. And laser triangulation, if the angle is too strong, it just reflects away, it's getting dark. With the confocal scanner, you just will get it. High resolution and with also this acquisition.
Okay.
This is a special fiber optical new interface which is used for embedded boards, fiber optical transmission.
Okay.
No, it's a coaxial transmission.
For long distance, basically.
For long distance, for embedded systems.
Yeah.
And but this fiber link is something that is typically used only on embedded systems, and the people have to do their own boards, customize their own boards. So it's not using this standard interface as what we use in machine vision, like USB 3 vision, GG camera link, or also meanwhile you use also other interfaces come like the MIPI CSE V2. In this case, it's a fiber link